Hi everyone, I am Prachi Agarwal. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Every week we'll post CodeChef problem explanations, conceptual videos on various programming paradigms, and also conduct live problem-solving sessions. But before we actually get started, here's a reminder to hit the subscribe button if you haven't yet already. Great! Now that you have subscribed, let's get started. Today we'll be solving the problem Self-Destructing Strings, which is a simple level problem and it belongs to the December Cook Off. Now let us see the agenda for today. So first we will see the problem statement. We'll try to understand what the problem wants us to do, and then we'll see how we can reach the solution. After that, we'll do a quick walkthrough of the code, which will be in Python. But before we actually get started, I have some great news to share with you. Did you know that CodeChef also conducts free live classes on Unacademy where we teach every possible topic related to competitive programming? We have beginner level courses like Introduction to C++ and Java, basic data structures. We also have advanced level courses like greedy problems, recursion, and advanced data structures, problems on graphs and trees. These courses are taught by the top coding experts who are IOI medalists, ICPC World finalists, and have worked in top product-based companies like Apple, Microsoft, Google, LinkedIn, Flipkart, and so on. So all you need to do is download the Unacademy app or register yourself on unacademy.com and choose your goal as competitive programming. You can also take the paid plus subscription to get additional benefits and individual level support. We have a large set of practice problems associated with every topic related to competitive programming. Also, we have 6-star and 7-star teaching assistants who will take up your doubts during the session and after the live session. So, you can use my referral code to subscribe to Unacademy. Use Prachi16 as the referral code and get 10% instant discount. So what are you waiting for? Hurry and start your competitive coding journey today. This problem talks about a binary self-destructing string. So first, before moving forward with the problem, let us discuss what is a self-destructing string. And after that only, we'll be able to understand the problem statement much better. So, let's call this self-destructing string S dash, and I have taken an example here 100110001. Now it contains a combination of ones and zeros. Why? Because it is given to us that a self-destructing string is a binary string. Now what are the properties of this string? So a string is called a self-destructing string if we can make that string empty by performing a certain operations on it. Now what are those operations? So the operation that can be performed is that we can choose two adjacent characters from the string which are different from each other, and we can remove those two characters. So what is written here? If I choose S dash of I and S dash of I plus 1 and it should not be equal to each other, then we can remove these two characters straight away from the string. So now since this string contains a combination of just two characters, that is 0 and 1. So, for the adjacent character thing, there is just 4 possibilities, and those 4 possibilities are, it can either be 0, 0, 0, 1, 1, 0 and 1, 1. Now, out of these 4 possibilities, which are the ones that are following this condition? So, only these two pairs are following our condition, that is S of I should not be equal to S of I plus 1. Or you can say that the adjacent characters should be different from each other. So we can only remove either 0, 1 or we can remove 1, 0. Now, since this string is a combination of ones and zeros, so every time we will be able to find out this combination, that is 0, 1 or 1, 0. Every time there is a transition from 0 to 1, then or from 1 to 0, then we will be able to find out these two pairs, and it will always be possible to remove them from the string. Let us see, can we make this string empty by performing these operations? And one more thing, that this operation that I talked about can be performed any number of times to make the string empty. Then only it will be called a self-destructing string. So now let us see that this example that I have taken, this is a self-destructing string or not. So as you can see here, that first time I am removing 1 0 because we have to choose two characters such that they should be different from each other and also adjacent to each other. So I have chosen the first two characters 1 0. And we will remove these two characters. So the leftover string will be 0 1 1 0 0 1. Now again we will choose two such characters which are different from each other and also adjacent. So I have chosen 0 1 here. Now if you want, then you can also choose 1 0. There is no problem, or you can also choose 0 1. So the order does not matter, you can choose whatever you want. So we need the ultimate result, that is our string should become empty. How it is becoming empty is not our concern. So I have chosen 0 1 here. Again we will remove these two characters and the leftover string will be 1 0 0 1. Again I have chosen 1 0, the leftover string will be 0 1, and we will be able to remove these two characters as well. And finally we have achieved an empty string. So yes, the example that I took was a self-destructing string. Now let us talk about the properties of this self-destructing string. If you observe closely, then this string is of even length. It is 1, 2, 3, 4, 5, 6, 7, 8. It has 8 characters in it. Now I can say that a string will only be self-destructing if it is of even length. How can I say that? Because we are every time removing a pair of characters from the string. Each time we find such a pair such that both the characters in it are different from each other and also adjacent in the string, then we can remove it. So if we are removing in pairs, then in case of odd length, there will always be a single character remaining which will not be able to find its, which will not be able to make a pair with any other character because it is of odd length. So you have removed 0, 1 0, then 0 1, then 1 0, then 0 1. So you can achieve an empty string. But suppose in this string if there was one more 0 here or one more 1 here, then we would have achieved here that extra character, that is either 0 or 1, that was added to this original string here, and we would not have achieved an empty string. So in case of odd length, we can always say that it will never be a self-destructing string. The second thing to observe is that the count of 0 and the count of 1 will be equal to each other if it is a self-destructing string. That means if the length of the string is n, that means here 8, then we will have n by 2 zeros and n by 2 ones in the string. Then only it will be a self-destructing string. Why? Because in each operation we are removing 1 0 and 1 1, right? So every time we are performing an operation, we are removing equal number of zeros and equal number of ones. That is why in a self-destructing string, there should be equal zeros and equal ones. Then only we will be able to achieve an empty string, which is the requirement of a self-destructing string. And this entire operation, since we are removing in pairs, it will always take n by 2 steps to become an empty string. That means if the length of the string is 8, then it will take 4 steps to become an empty string. And you can also see in this example here that we have equal number of zeros and equal number of ones, that is 4 ones and 4 zeros, and it is taking 4 steps to become an empty string, that is n by 2 steps, because each time we are removing a pair. That is why it will take n by 2 steps. Now that we have understood what is a self-destructing string, let's move forward in our question. Now in the question, we are not given a self-destructing string. Rather, we are given another string s which is also a binary string, and we have to convert this string s into a self-destructing string s dash. So this s dash I took in the previous example as a self-destructing string and showed you that how this string was getting empty. Now we have to do the same thing with the string given to us, that is s. We have to convert this string into a self-destructing string. Can we do that? Let us see how. To convert this given string s into a self-destructing string s dash, we can perform the following operations. The operation is just similar to what it was in a self-destructing string. We have to choose two characters adjacent to each other such that they are different from each other. That is, s of I should not be equal to s of I plus 1. That means again we can either choose 0, 1 or we can either choose 1, 0. Only two possibilities. And what we have to do this time, we don't have to remove these characters, right? Because we know that our given string s may or may not be a self-destructing string because we are converting it into a self-destructing string. So this time we have to invert one of these two characters. So we can either, if we have chosen 0, 1, then we can convert either 0 to 1 or 1 to 0. That means what are the combinations that can be possible? So if we have chosen 0, 1, then we can make it either 1, 1 or we can make it 0, 0. So this is how we are going to try and convert our string s into a self-destructing string. Or if we have chosen 1, 0, then same thing, we can either convert it into 1, 1 or we can convert it into 0, 0. So this is the meaning of inversion. And we have to find out what is the smallest number of operations required to convert string s into a self-destructing string s dash. So how many number of operations, that means the smallest number of operations are required such that we can convert our string s into a self-destructing string. Now it may not always be necessary that the given string can always be converted into a self-destructing string, as we already discussed that there are some conditions pertaining to a self-destructing string, like it should be of even length and it should have equal number of zeros and ones. So all of those things are there. So it may be possible that we are given a string of odd length and there are some corner cases as well. So in that case, it will never be possible to convert the given string into a self-destructing string. So if it is impossible, then we have to determine that as well. Now let us try to convert our string s into a self-destructing string. So first time I have chosen 0, 1 because we are to choose two adjacent characters which are different from each other. So I have taken 0, 1 here, and what I'll do is I'll invert this 1 given here into 0. So I have made this 0, 1 as 0, 0. Now again I have chosen 0, 1 here and I have converted this 1 present to 0. So I have converted 0, 1 to 0, 0 again. Now this string, as you can observe, is s dash that I took in the previous example of showing that how a self-destructing string works. So this is our self-destructing string given here. So we have converted our original given string s into a self-destructing string in just 2 steps. But how are we to decide these that how many number of operations our string will take to convert into a self-destructing string? There should be some math related to it, right? So let us discuss that now. So guys, we have already discussed all the properties of self-destructing string. So if we have to convert our original string into a self-destructing string, then we have to ensure that s also follows the properties of s dash. The first property was that s dash is should always be of even length. Only then it will be a self-destructing string. So that we can check. And otherwise, if it is of odd length, if s is of odd length, then it can never be converted into a self-destructing string. Second property was that the count of zeros should be equal to count of ones. Then only it will be a self-destructing string. because each time we were removing pairs 0, 1 or 1, 0 from the self-destructing string. Now, I am very sure that this question will arise in your mind, that why is it always true that if we have equal counts of zeros and ones, then we can ensure that we will achieve an empty string. So, because each time we will be able to find a certain pair 0, 1 or 1, 0, no matter whatever we have in between, a combination of zeros and ones. So we will always be able to find a transition from 0 to 1 or from 1 to 0 if we have a combination of zeros and ones in the string. And the order does not matter. Why? Because just look at this example. If we have a lot of zeros here and then a combination of ones in between, then we can remove these two characters 0, 1. Now, after removing these two characters, we will again be able to achieve the combination of 0, 1 or 1, 0, because again there will be a transition if there are equal number of zeros and ones. So that is why it will always be possible that if the count of zeros and ones are equal, then we will be able to achieve an empty string. That is why this is the most important property of a self-destructing string. So this property only we have to ensure that our original string also follows. So essentially our problem reduces down to making sure that our original string consists of equal number of zeros and equal number of ones. And whatever number of zeros it has more or whatever number of zeros it has less, we have to make them equal. We have to make the zeros and ones equal. So this is very simple mathematics, right? We can count the number of zeros here and we can count the number of ones here. So say in this original string right now, we have the zeros as 2 and we have the number of ones as 6. And we need equal number of zeros and equal number of ones. That means we need n by 2 zeros and n by 2 ones, right? So n is 8 here. That means we need 4 zeros and 4 ones. So if we calculate the difference between the zeros and ones, that is 6 minus 2 equals to 4, and we divide it by 2, then we will be able to achieve the number of zeros or the number of ones which are lesser or more in the given string. And those many number of inversions we will have to make in order to ensure that we have equal number of zeros and equal number of ones. That is what we are doing in the problem. That if we have the count of zeros less than n by 2 or we have the count of ones less than n by 2, that means half of the length of the string, then we have to convert those many ones or those many zeros to 1 and zeros respectively. So we will be able to do that by calculating the difference between the count of 0 and 1. Say the difference is k, then k by 2 will be our answer. The difference between the count of ones minus count of 0 divided by 2 will give us the smallest number of inversions required in order to convert our original string into a self-destructing string. So guys, this was our problem. Now coming over to the input, output and constraints. The first line is as always the number of test cases, and for each test case we will be given a single line which contains our string, which is to be converted to a self-destructing string. And for the output we have to print a single integer that contains the smallest required number of operations to convert our string into a self-destructing string, or we will print -1 if it is not possible to convert the string into a self-destructing string. And the constraints, so as you can see, for the number of test cases it is 1000, and for the length of the string it is up to 10 to the power 6, which is quite a high number. So if you try to do some kind of brute force approach, then it will not work. You will get a TLE as your answer because it is 10 to the power 6, which is very high, and S only contains 0 and 1, so that this we have already established that our string is binary in nature. So guys, now let us proceed to the code which will be in Python. Okay, so now let us discuss the code. So first line of input, as always, is the number of test cases. We have taken the input for it, and we are running a loop so that we can achieve the input and we can do the calculation for each test case. Here I have taken the input for the given string that we have to convert into a self-destructing string. Now after that, what we discussed in the problem, that we have to count the number of zeros and the number of ones in the given string. So that is what we are doing in these two lines. We have a count function in Python which we can use to directly calculate the count of any character present in the string. So we are doing that. Zeros contains the count of zeros and ones contain the count of 1. Now this if condition, it decides that we cannot convert our given string s into a self-destructing string. And what are the conditions for that? The first condition I have already discussed with you, that if the given string is of odd length, then in that case it can never be converted into a self-destructing string. So that is what this condition is talking about. Or there are also two other possibilities when the given string cannot be converted into a self-destructing string. That is, if we have all zeros or all ones present as a part of the string. That means our string is not a combination of zeros and ones anymore. And as I already told you, that we required to select each time 0 1 or 1 0, even for the conversion of the given string into a self-destructing string. That was the requirement of our operation. So we will not be able to perform those operations in the given strings here, even if our string is of even length. So that is why I am checking here that if the number of zeros present are 0 or the number of ones present are 0, that means the string contains all zeros or all ones, then in that case also the answer will be -1. That is, the given string cannot be converted into a self-destructing string. Now we'll come to the else part, where we have ensured that now our string can always be converted into a self-destructing string. So here we are just calculating the absolute difference between the count of zeros and ones, and we will divide it by 2. And I'm using floor division operator here, which gives us the floor division value, that is the integer value of the division. So after that we will just print the answer, and done guys. So this is our code. Now if you understood the problem, then please like this video and subscribe to our channel. If you have any doubts or feedbacks, then you can post it in the comment section and I'll be happy to help you. Also, I would like to tell you that please submit this problem even after the contest is over, because it will enhance your competitive coding practice.